So Arjun, the question is very clear that the kinetic energy of a body decreases by 90%. Find the percentage decrease in its linear momentum. Now the question says that your kinetic energy of a body is decreases by. So suppose initial kinetic energy was K initial is K, and of course because the linear momentum is also involved, so we can write that it is P square by 2m, and the point is that this is the initial kinetic energy. Now this kinetic energy is decreased by 19%. So if it is decreased by 19%, so this will give you the final kinetic energy K dash, and that will be K minus 19% of K, and this will make it 81 K by 100. So the new kinetic energy would be 81% of the original one, and of course the momentum would be P dash equals to root 2m K dash. That makes it root 2m K dash is 81 K by 100, and this makes it 81 is 9 by 10 root 2m K. This is P dash. Here P would be root 2m K, okay, and P dash would be 9 by 10 times root 2m K. That makes it P dash is equals to 9 by 10 times P, the original momentum. Now what we have to do? We have to find the percentage change. So percentage change would be del P by P into 100%, and that makes it P dash minus P divided by P into 100%. Okay, so P dash is what? It is root 2mk, root 2mk dash, or in fact P dash is 9 by 10 times root 2mk. So you can write it 9 by 10 times root 2mk minus root 2mk, that is the original root 2mk momentum, divided by root 2mk. Now root 2mk will be common and cancel, so 9 by 10 minus, it will be 9 by 10 minus 1 into 100%. So this makes it minus 1 by 10, I guess 9 minus 10. So it will be minus 1 by 10, so minus 10%. So it means that the linear momentum would be decreased by 10%. Now this question says a shot is, the bullet is fired, okay, a shot traveling at the rate of, it is traveling at the rate of 100 meter per second. It means that its speed is 100 meter per second, is just able to pierce a plank, just able to pierce a plank 9 centimeter thick. It is just able to pierce a plank which is 9 centimeter thick. So what should be the velocity? Required? What should be the velocity required to pierce a plank? Pierce a plank which is 9 centimeter thick. Okay, which is 9 centimeter thick. So this is the question. A shot traveling 100 meter per second rate. So the point is, its initial speed is 100 meter per second, and it is just able to pierce. So you see, initial velocity of this, say v1, is 100 meter per second. First we are talking about first case, and it is just able to pierce a a plank of just 4 centimeter. Here it is 4 centimeter. It's not 9. Otherwise you won't be able to find it, right? Was V1 is given 100 centimeter, 100 meter per second, and a 4 cent, it is able to pierce a plank of 4 centimeter. Just able to means कि बस ये बुलेट यहाँ पर बस पहुंचेगी ही सही, है ना? तो इसका क्या मतलब हुआ? अगर आप वर्क एनर्जी थ्योरम यहाँ लगाओगे, W इक्वल्स टू 1/2 m v1 स्क्वायर माइनस 1/2 m u स्क्वायर, तो इनिशियल वेलोसिटी इतनी है, फाइनल वेलोसिटी क्या हो जाएगी? फाइनल वेलोसिटी वुड बी 0. So if you apply work energy theorem here, it will be 1/2 m v1 square minus 0. Okay, and that should be equal to force into displacement. What is the displacement? It is 4 centimeter here. If you want, you can convert it into meter as well. So this will give you 1/2 m v1 square minus 1/2 m minus 0. So 1/2 m v1 square is 100 square. Correct? This will be equation number 1. Right? Then there is another thing. Now you have 9 centimeter thick plank, and a bullet is going inside, and what happens? How much velocity should be there? So we don't know, so we'll write v2, and final velocity would be 0. Correct? So it will be W equals to 1/2 m v2 square minus 0. Now force would be same because resistive force is not going to be changed. So force into displacement. Now this time displacement would be 9 into 10 to the minus 2, and that is equal to 1/2 m v2 square. Correct? Now we have equation 1, equation 2. These two equations are there. So let's take the we have to find v2. So let's take the ratio. If we take the ratio, then this will give divided f into 9 into 10 to the power minus 2 divided by 1/2 m, and it will be v2 square, right? So f and f will cancel, 10 minus 2 will cancel, 1/2 m will cancel, v2 will go here, so it will be v2 square divided by v2 square is equal to 9 will be multiplied here, 9 by 4, so it will be 9 by 4 into 100 into 100. Okay, so v2 would be under the root of these all, and that makes it 3/2 multiplied by 10, no, multiplied by 100. So this makes it 50. 53s are 150. So velocity to pierce this 9 centimeter thick wooden plank should be 150 meter per second. Now next question says that a particle of mass 0.5 kg travels in a straight line. It travels in a straight line with a velocity of with a velocity of v is equal to 5x to the power 5/2 meter per second. How much work? Question is how much work? Now certainly it is clear that velocity is varying with displacement, okay, or the position of the object. How much work is done? How much work is done by the net force? How much work is done by the net force during the displacement during the displacement x equals to 0 to x equals to 2 meter. That's the question. This particular method, what I am suggesting you is, see, we have to basically find out the work done. Work find करना है और अलग अलग displacements x equals to 0, x equals to 2 meter के लिए हमें ये given है. So velocity, it is clearly mentioned that the velocity is varying with displacement, isn't it? v equals to 5 x to the power 5 by 2. Now the question is, when x is 0, we can consider it as initial velocity u, and that will be when x is 0, and that velocity would be 0 meter per second. Secondly, when you substitute x equals to 2 here, so that makes the velocity final velocity, and that will be 5 times 2 to the power 5 by 2 meter per second. Now the question is, how much work is done? You have initial velocity, you have final velocity. The only thing you have to do is you have to find the work. You know by work energy theorem, 1 by 2 mv square minus 1 by 2 mu square, and this makes it 1 by 2 mv square is 1 by 2 m common. V is 5 x to the power 5 by 2, its square is there, 5 square is 25, x to the power 5 by 2 square is there, so that makes it, okay, don't do that. Final velocity is 2 to the power 5 by 2, so into 2 to the power 5 by 2 square, that makes it 2 to the power 5 minus initial velocity, it is 0. Okay, so this will be 1 by 2 m is 0.5. 0.5 means 1 by 2 into 25 into 2 to the power 5, we can write it 2 to the power 3 multiplied by 2 to the power 2, this is cancelled. 2 to the power 3 is 8, 25 8s are 200, so 200 joules should be the answer. This is the answer of it.